welcome everybody, as Karim said, to this Tech Talk on a Thursday morning, almost weekend. So we're gearing up for that. So this morning we're going to touch on a couple of common failures for solar. But before we get there, just remember the normal protocols for that we all should go through to prevent COVID, the spread of COVID, should I say, not to prevent it, that's a bit late for now, but to prevent the spread of it rather. Okay, so as I said, we're going to have a look at common solar failures or common solar complaints. When a customer picks up the phone and phones the plumber and says, listen, my solar system is doing this, that, and the next thing. So we customers aren't technical, so they don't know the technical terms, so they'll come at you with very layman's terms, and we can try and should we say interpret those as to try and what the system's doing or not doing or failing at, etc. So this isn't comprehensive, guys, as usual. I mean, we haven't got 4 hours, so this is a 25 minute tech talk, so it's pretty high level. But I just want to say that when I say, for example, just to illustrate that you just need to think a little bit deeper into the problem. So when I say, for example, it's a faulty probe, or it could be a faulty probe, it's not just the actual bullet at the end. It could be a damaged wire. It could be a wire that is running in the roof that somebody has stepped on, damaged, broken. It could be pulled out of the controller. It could be the probe. The probe itself could be damaged. It could be have pulled out of position. So the whole length of, think backwards along the line of that particular problem. And I'll do my best to try and illustrate what a problem is when a customer says that, this thing. So for example, my TP discharges often, or they won't use the word TP, but they'll say, often my solar system is discharging or gushing hot water, whether it's onto the roof or out of a pipe or something like that. You can think that the TP is discharging often. Note the word often, and you would ask the question, is it intermittent? Is it happening consistently? What sort of flow rate is happening? I mean, is it a hose pipe? Is it a drip? Is it a trickle? So you ask these questions. But if the TP is discharging often, one can infer that there is too much temperature in the system, because if it's a discharge which happens every now and again, one knows that it's not a pressure problem, because a pressure problem would be consistent. Anyway, so you ask if it's a new occurrence. If it's a new occurrence, so it hasn't been happening forever and it's only a recent occurrence, then it could just be that it's a hot summer day, and that's par for the course. Solar systems are subject to constant UV, and you cannot switch the sun off. So it could just be that it's a hot summer's day and it's par for the course. So how do you test that? You ask whether it is, usually it will be in your area, so you'd know whether it's a very scorching day. So you ask the question, I mean, does it only happen on very, very hot days? How often does it happen? You disseminate the problem. Other than that, it could be a system mismatch in terms of a collector being slightly oversized, or the tank being undersized for that matter. There could be a change in habitation. In other words, maybe somebody's just moved out of the property. A youngster who, like, I've got 2 daughters now. If when they stop showering, half my hot water usage will disappear. So that could be a change of habitation or water usage patterns. Has there been, for example, any shading removed recently, like a tree that has been cut down close by that used to shade the system but now does not shade the system anymore? Has it been recently serviced and cleaned out? Could have been sludge in the system. Perhaps they've removed that and it's now more efficient. Otherwise, it could just be timer settings or faulty probes, or the probes themselves that are out of place, or the controller that is not working. So timer settings would be where the electrical boost kicks in early in the morning and heats that geyser fully before the solar, or before the sun comes out, and has a chance to heat it with the solar radiation. So you're starting off the solar radiation heating cycle with a very hot geyser already, and that's a problem. So you've got to leave what I call, in inverted commas, space in the geyser with your electrical settings so that your solar can kick in and have space to heat? If the answer is no, it's not a new occurrence, it's been occurring quite often for a while, or as far as I can remember, it's a different set of circumstances. Then you've got to look at more permanent problems, like the collector is, in fact, too large for the tank. Perhaps it's a holiday home. That where nobody really lives there 7 or 8 months of the year, and that could be a problem. And then the usual timer settings or probe being faulty. If it's a constant discharge, like, well, constant occurrence, there's a design problem. It's not designed properly, or it's not being treated properly, or it's not being handled properly by the owner. For example, a holiday home solar system, I don't really like those because obvious reasons. You can't switch off the sun. The thing sits there for 6 or 8 months of the year, just boils. So you've got to talk them through covering the collectors and making sure that it doesn't receive that radiation while there's nobody in occupation. So that's a more permanent sort of a problem. So that's the TP discharging. What about a very low temperature in the morning? Man, I wake up and there's no hot water for me in the morning. Okay. Does that mean that there's heat loss? Probably. There could have been heat loss in the system. So the lagging could have been damaged or perished or disappeared, or not there at all. If it's a thermosyphon system, I beg your pardon, if it's a pump system, we know about reverse thermosyphon. So with a pump system, you have a situation where the solar collector is above the level of the tank, and heat wants to rise. Hot water wants to be on top. It is lighter, it is less dense, and therefore it weighs less. It weighs less than cold water, so it wants to float to the top, and it will find its way there through the flow and return pipes of a pumped system. If that pump system does not have some sort of prevention of reverse thermosyphon, so the phenomena of thermosyphon will continue until you put a non-return valve in there to say, no, you may not reverse thermosyphon. What happens when you reverse thermosyphon? The tank is low, the panel is high. From the hottest portion of that tank, which is the hot water outlet, or the not the hot water to the taps, but the hot water to the panel. In other words, the return from the panel into the tank at the highest point, that will start to flow back towards the panel, and the cooler, dense water will want to drop back down from the panel, which has now been cooled by the atmosphere, and drop back down into the geyser, and that circulation will happen. And eventually you will essentially lose all of your stored and captured heat from the geyser into the atmosphere overnight. So you will start off with an ice cold geyser the next morning. That's reverse thermosyphon. So it could be reverse thermosyphon. It could just be that the system is too small. And when I say too small, I mean smaller than recommended in terms of if you look at the sizing requirements of solar systems. The sizing requirements of solar systems per occupation of the building is such that you are able to use hot water during the day when it gets heated, top it up as necessary so that you've got sufficient hot water, but overnight and tomorrow morning, you've got a little bit left over to start or to kind of push start the whole system again tomorrow. So you don't deplete the entire storage of hot water or on a given day. There's always a little bit left over just to give the system time to sort of get back into things. So there always should be a little bit of hot water, or a significant amount of hot water the next day in a solar system if it's properly sized. So if there isn't, and it means that you have depleted the entire storage for a day and your timer settings are not correct, it means that your electrical boost is not kicking in time. Now, that's tricky because if you don't want to electrically boost, as we've seen already, where you've got a geyser heating up to its maximum temperature, 60 degrees, before the solar kicks in. So you just want to electrically boost to a very limited temperature. and allow the space for the solar then to kick in. Guys, this is also important to remember the difference in design between a solar geyser and a normal geyser, whereby the solar geyser usually has an element which is placed much higher in the tank than a normal conventional geyser. So even if the solar geyser electrically heats itself quite hot, you've still got a lot of space, and inverted commas again, of cool water below that element, which will allow for the solar input, the thermal solar input, to circulate and not overheat the cylinder. Okay, so it could be a small system with the wrong timer settings. Again, probes that are faulty or out of place, the controller not getting the correct signals and not doing its thing. If it's an indirect system, check that the heating fluid, in other words, the glycol mixture, usually is a glycol mixture, is there. It is topped up and it's behaving itself properly. If it's an indirect system talking about heating fluid and the relief valve is constantly discharging, I'm talking about constantly discharging without stopping, it means that there is a back pressure situation and there is a ruptured coil or a tank in a indirect system. If there's pressure coming from the potable water being pushed into the non-potable side of that thing, that relief valve will constantly rupture, at least discharge, beg your pardon. So an indirect system relief valve, sometimes discharging. In other words, intermittently. I've seen it discharge a few times, and now my solar system isn't working so lekker, but I have seen a bit of a dripping, and it's from this thing, and it's on the side of the geyser, and it's not the normal one, but it's the other one. So that's the indirect system relief valve, but it's intermittently discharging. Remember, guys, that an indirect system's heating fluid is non-replenishable. It does not replenish itself. It's not attached to some magic tap with glycol water mixture that keeps replenishing it. When it expands and drips onto the roof, that's it. It's gone. You've lost it. So with an indirect system, some of the systems have built-in expansion tanks, and some don't. You need to have an expansion tank there. So if it discharges, you will have air in the system, and we all know that air disrupts whether it's a thermosyphonic flow or a pumped flow, it will disrupt it. So there needs to be an expansion tank. If you don't have an expansion tank, you are going to lose glycol mixture, and the system is going to lose performance. I'm not saying it's going to stop performing altogether. You won't lose it all, but you'll lose some of it, and there will be some air in there. So you'd need to have an expansion tank that can accept the expansion and then replenish that fluid when the system cools down again. Okay, then just general non-performance. Now, this is obviously a broad spectrum, so you'd need to ask a number of questions, and you'd need to, I always like to try and get a timeline when a client says, well, it's just not working. Okay, that's very broad. You mean there's no hot water? You mean it's exploded? Do you mean that it's just not working this morning? Do you mean it hasn't worked for 3 weeks? Give me an indication as to, just give me more context and more details. The more detail that the client can give you, even though they don't know that it is sort of pertinent to the system, just ask them the questions and get as much info as possible. So essentially, is it a new behavior? If it is, when new could be a couple of weeks, couple of days, maybe even a few months, it's still a new behavior. If they've been there for 10 years and the last 3 months, it started to do this. So could have been a sludge buildup in the system. We know that sludge is a thing, and that could be both in a tank or in a panel. So there could be sludge in either one of those, or sometimes both of those. Especially a thermosyphon system, you must think to yourself that thermosyphon the flow pressure of a thermosyphon system is actually quite light, and it's not a lot of pressure. So it's very difficult for it to overcome initial obstacles. So if there's a little bit of sludge in the line or somewhere, it would cause that. Faulty pumps do pack up. That's why we install them over trays. That's why we install them with lever ball valves on either side of it so that we can easily isolate it. That's why we install pumps with union type couplings on the pump so that we can shut off, remove the thing, hassle free, pick it up, look at it, service it, clean it, put it back, or replace it. And so pumps do pack up. Lagging could have fallen off, could have disintegrated or started to disintegrate, and it could just be a matter of heat loss. And that could also count. That could be the same for a geyser. Perhaps the outer casing has become damaged, and the insulation is now waterlogged for some reason or whatever. It could be the collector position or size, and I think of shading that tree that grows into place. Or it could just be a generally small or undersized system. Okay. In other words, not big enough to accommodate for that size storage. So there's not enough solar energy coming in. There could be a hot tap that is leaking or dripping, or in fact, it could be any other source of hot water leak. That is, as we all know, a hell of a drain on a system where you've got hard-won heat energy stored in this geyser or hot water, and you've got a 10-liter an hour leak in a hot water line. That would just suck all of that away. Shading, as I've said, it could be something that's recently grown. It could be a sign or a billboard that has just gone up next door. It could be a building that has just gone up next door. It could be one of your own buildings. Perhaps you've just built a lapa that is next to, and it started to shade that collector, or any number of things could cause shading. And then the other obvious line of questioning is an electrical one. The sensor probes, the controller itself, the electrical supply to the tank, the electric heating, the timer settings. Are they correctly timed? Have you taken into account the behavior of the people that live in the property? And are you boosting at the correct times? All these questions must be asked. So to have a very vague complaint like that is quite a tricky one. As I say, the more questions you ask and information you get, the better. And the better you are able to start figuring out what's going wrong. So this is quite a common one, and it is often misdiagnosed as just a normal plumbing problem like water hammer. So it often occurs on hot days, and there's an intermediate or an intermittent hammering noise. And that is what happens in a solar system, is that if there is opportunity for air to develop in, especially and usually pumped systems where the collector is above the geyser, air will start to collect, and it will always migrate to the top of the system, which is the top of the panel, which, by the way, is the hottest part of the system on a hot summer's day, because the sun is beating down on it and all that heat rises to the top, and that copper is extremely hot. It's superheated. It's hotter than what boiling water is, and but there's no water for it to transfer its heat into. It's full of air, or there's a little pocket of air somewhere. And it's superheated. In other words, it's hotter than the boiling point of water. And what happens is, as soon as you put or force water through those pipes by means of the pump switching on, the temperature probe will sense that the panel is hotter than the storage, and it'll switch on and start to circulate, and it'll force water through those pipes. Those pipes are 180 degrees or whatever. Water comes in, it's relatively cool, and it flash boils. and it creates these little mini explosions. And so what you're hearing is not really water hammer. It's actually little explosions of water droplets flash boiling into steam and rocking that system's that system is not a happy chappy. So the what often happens is that it happens intermittently when pumps switch on. So it's not something that one would attribute, or a homeowner would attribute to when I open this tap or when I've done this. And as soon as I do that, it's a kind of a random occurrence, because it's when the pump switches on. And she'll say, every now and again, this damn thing sounds like it's going to come off the roof. So what do? We have to allow the air to escape from a system. And we do that by means of an air release valve. So any pump system will have on the solar collector will have a air release valve. Now, those air release valves are also just valves. They are fallible, and we have to make sure that they are working properly. I've seen ones that have melted because the inside is just a little float with a little washer and against a little opening, almost like a float valve, very similar. But when there's water in this little chamber, it lifts that float and it blocks the little air hole. When there's no water in the chamber, in other words, when it's full of air, that float drops and air is able to escape through the little escape hole. And then the water arrives and it lifts it and it closes it. But sometimes these things are faulty. I've seen one that's melted off completely, not the casing, but the inner plastic workings. Remember, you get high temp and you get low temp versions of the air release valves. The thing could just be damaged. That's your first port of call. Go and have a look why there's air in the system, and make sure that you've done something to get rid of that air. And I can guarantee you 90% of the time, even 95% of the time, that noise disappears and that phenomenon disappears. So as I said, it can happen either when the circulation of the pump starts to kick in, or sometimes when the client uses hot water and sort of forces a bit of a flow through there. So stagnation is another one. I must hurry up. Stagnation is when and clients won't be very able to, or they won't be able to describe stagnation to you and say that we use the word stagnation. They'll just say, yes, see, I've looked at my geyser controller and there is a massive discrepancy between the temperature of my tank and the temperature of my panel. My panel's so hot and my tank, it's not getting any heat. So that's stagnation. In other words, the flow has stopped. So if it's a thermosyphon system, then the primary loop could have some kind of obstruction, whether it has a backfall, whether it has a sludge in it, whether it has a valve in it that has been installed somewhere, whether the pipe itself is kinked, or the panel itself. That is the other thing, whether if the primary loop doesn't have an obstruction, the panel in a thermosyphon system needs to be inclined at an angle sufficient to allow for the thermosyphonic flow to happen. Okay, there could be a problem with the height differential between the panel and the tank. So if the tank is lower, or not lower, but if it's almost as low as the top of the panel, your flow won't happen so lekker. And the slightest bit of sludge, something that wasn't there yesterday, today, will stop that flow. So you've got to make sure of your falls and everything. If it's pumped, the same sort of obstructions as above. Perhaps somebody climbed in the ceiling, stood on a pipe, kinked it, and now it's obstructing the thing. The pump could be faulty, simple. Or again, the electrical side of things, controller, probes, timer settings. Well, not timer settings really, I suppose, but perhaps the probes or controller doesn't know when to switch the pump on and has refused to switch the pump on. Perhaps the pump itself is jammed, or whatever the case may be. So that's stagnation, when there's a big discrepancy in temperature between the panel and the tank. And then the last one is when I open the tap, I nearly get burnt to death. 80-degree water coming out of the tap. Well, guys, it's quite simple. We know that a solar system will get to these temperatures. It's the nature of the beast. It's a solar system. And you need to just cater for it. So it's a requirement to put in a tempering valve, which is a valve which introduces cold water into the flow of hot water from the tank to the terminal fittings. It doesn't allow water through it, which is hotter than 55, 50 odd degrees. And if it is hotter than 55 degrees, it introduces cold water into that flow, so that when you open your tap at the terminal fitting, it is 55 degrees or there and thereabouts. And if that's not there, or if it is faulty, or if it is installed incorrectly, you've got scalding water at the taps. And yeah, as I said, guys, that's a high level, but I hope it gave you a couple of pointers, perhaps one or two little things that you didn't think of before. I don't know if there are any questions, Karim. We're about 25 minutes past, so it's reasonably on time.
Thank you very much, Richard, for the informative session. We do have a comment and a question. The comment is, just check the lifestyle with the client to set the timers that will suit the client's lifestyle.
Absolutely. The way that the client behaves and when they blute, when do they shower? Morning, night, both? You know, do they have extra people in the weekends? The lifestyle of a household will determine 80% of the settings of a solar controller. Absolutely spot on.
Yeah, thank you. And then the question is, the 220 volt pump, is that installed horizontally or vertically?
It can be installed either way, but the spindle, in other words, the shaft of the pump must be horizontal. So if you think, if it's on a vertical pipe, then the shaft is horizontal. So the shaft of the pump is horizontal, so it's fine. If it's on a horizontal pipe, you've got to swing that pump to its side, so the shaft is horizontal. If you face it upwards, that shaft is vertical, which is a no-no. And if you face it downwards, that shaft is a vertical, which is a no-no. So as long as the shaft of the pump is horizontal, you're fine.
Okay, perfect. I see we've got another question. What should you do on a pump system with an extreme geyser when the pump is switched on? It pushed the hot water through the cold water pipes when you open the cold taps. Installation is correct.
Well, the installation can't be correct. It can't be. You've got a connection. Yeah, if it's an extreme geyser, there should be a port for your cold water draw from the geyser to the panel, and a port for your hot water return into the tank. So there shouldn't be any cross connection between primary loop and reticulation pipes. I would double check that installation. If you say forgive me, but this is a very short amount of time to try and think about this problem. You say when the pump switches on to start to circulate the solar system, the cold water taps water becomes hot. So I would ask the question whether that is only when the pump switches on. And if the answer is yes, I would say, how do you know that it is only when the pump switches on? If I'm getting hot water out of cold water taps, I am looking for cold water pipes that are in the sunlight, that are in walls that are in the sunlight. And I'm looking for that sort of reason. And that might be the answer rather than attributing it to the pump of the solar system. I don't think that the two are connected. I would ask a lot of questions around that, and I'm looking for other causes already. But I might be wrong. If you want to have a chat about that, feel free after or off air. It sounds like an interesting one. We can talk about that. That's it. Thank you very much.